Hey everyone, so today we will be talking about another interesting topic, which is the differences between the cloud computing and the edge computing. So first, if I talk about the differences, I should definitely talk about what is the cloud computing and what is the edge computing, so that at least from the technical definition perspective, you can understand some of the differences. But I will be talking about the differences in a broader way after explaining what is cloud computing and what is edge computing. So in cloud computing, the idea is very, very simple. Let's say earlier you were doing something on premises. On premises means, take very simple example. You created an web application, right? You created any kind of software, and to make it functional, or let's say it can be accessed by the customer, right? Let's say you created an food delivery application. So you need to host it somewhere. And let's say you are an organization and the cloud is not there, and you cannot let's say afford cloud, or you don't want to go on to the cloud. So you need to buy those machineries, you need to buy those high computing machineries, servers, commodity hardwares, right? So that you can set up your own thing on premises. And that is what we call the on premises. Anything which is owned by you and maintained by you, right? Or any kind of device, physical device, the infrastructure, everything, it is, if it is owned by you, that means the solution is on premises. So your application will be deployed there. You will install softwares there, your different frameworks, let's the different languages, database, right? These kind of things you will install, and then you will completely spin up your application and it will start executing there. Okay. But let's say you don't want to bother about it, right? Because this is also looks like a very, very tedious task, like maintaining everything just back in the head. You need to take care, okay, this shouldn't break, and I am the owner of it, and I need to take care everything from start to the end, the application logic, creation, everything. Okay. So that's how the cloud computing came into the picture, where somebody don't need to bother about the typical infrastructure related thing, typical basic fundamentals you need to actually make your application executable. You actually need to just focus on your application logic, and everything will be taken care by someone else. And those infrastructure, those servers, those databases will be hosted on a remote location, right? And as soon as you need it, you just raise a request, you will get it. You can even scale your things with the multiple instances of it. And that is what cloud computing, like getting anything on demand over the internet, over the web, is actually cloud computing. And what you are demanding can be anything. It can be any storage service, it can be any database, it can be any networking capability, it can be any platform itself, it can be even as a software as a service you can get it, and even an infrastructure as a service. So everything you can get it on demand, and that is what cloud computing is. Now if I talk about the edge computing, so edge computing, in a first line, if I explain it, you might find it confusing, but you will definitely get the idea of edge computing when I will explain it with the help of example. So first, let's listen this technical definition. So it is nothing, basically the networking capability, or you can say a methodology where we are trying to bring the computation, the actual computing part which was happening over the cloud, as near as to the source data. And nowadays anything, like even your mobile application, your mobile device is even actually the source of data, because you are using the application, you are generating something, anything will be like captured as a data, and that can get processed. Okay. And whatever instruction you fire, that will be actually getting like processed somewhere else, right? Just the application is installed in your mobile phone. So this is the thing, right? We want to do it here. The computation part, whatever heavy computation or anything is happening, right? Just try to bring it as near as to the source of the data. That is the edge computing. So why edge computing is getting really popular nowadays? Because of the its power of minimum latency, right? You get the least latency, and latency means something which you are getting in the very, very quick span of time, right? Basically time duration taken for any action or anything. So nowadays the idea is, or the world is actually moving more towards these streaming things, right? You actually love live streaming. Any event is happening, you don't want to expect any lag, right? Let's say you are eagerly waiting for any match, right? The cricket match, football match, there are different kind of web streams, right, available platforms, or even the companies, let's say the Netflix, Amazon Prime, Hotstar, anything, they have created these kind of services where on a real time you are getting that data for you, and you are just sitting on a remote location. You can even imagine that very very long distance. Let's say you are sitting in a London and match is happening in India on a real time without even a fraction of the seconds of the lag. You are just getting the exact complete live streaming. So that is happening over the cloud, right? The infrastructure, the whole setup of this application is quite complex, and that is the main idea to introduce this edge computing terminology in the cloud along with the cloud computing, right? So this concept of edge computing will definitely minimize the time taken, right, the latency part between the client and server, because you are sitting here, you are a client, server will be somewhere else which is actually responding you. Okay, so that is the main part. Latency is something which means a lot nowadays, right? Nobody wants any kind of lag, and that is why we need some kind of methodology or some kind of architecture system which can help us with that. Now I was talking about the example how you can understand the computation part and what is the edge computing. So let's take an example, right? You are basically kind of owner of any society, or let's say kind of authority who has created some buildings or took the ownership of buildings and installed some like camera devices there, right, on different sections. So it's a basically very very high secured building, right? And different like can be suspicious activities may happen, right? And you would like to only capture those kind of clips. So those camera devices are very very dumb devices, you can even say, right? Whatever they are capturing, right, even something is not moving, they will just keep just capturing that footage and will keep on setting. And let's say you have installed 1000, 2000, 5000 of camera in that highly secured building. So you can even understand the load, because that is something, if the footage is transferring from source X to Y, obviously it needs the internet. So while transferring that data, the footage, like in a real time to any some location, right, that will consume hell lot of internet bandwidth. Okay, and that will like you shouldn't expect let's say the video was captured, you are going to get it in next second. Probably you will get it in after 30 minutes or 1 hour, and till that time damage would have happened. And that is the main purpose, right, to secure that building. If any motion is happening, right, you will try to instantly capture it and would like to take the action. So just think a very very simple logic, why I'm putting so much load to the actual computing server, right? Let's say those raw footages we are sending to that server, and that server is after running some algorithm to just select those raw clips where some movement is happening, right? We are unnecessarily wasting the internet bandwidth or even the computation which is happening. So the idea was make those cameras or put some layer just close to the cameras. What it will do, it will do the computing in a pre-phase, like pre-computation itself, like whatever image or whatever footage that particular camera is capturing, it is checking if the motion is happening, only that footage will be sent to the main computed part wherever the computation is happening, like raising the alarm or triggering a security alarm or something. Okay, so that actually makes sense, and it will save a hell lot of bandwidth, and our like things or streaming will be completely fast, because I am only actually concerned about those footages where some activity or motion is happening. You can get the idea, right? We try to just build some layer or some logic just near to the data source itself, which is doing some pre-computation itself in its own, that is the edge, right? And on the edge some computation is happening, and then it is moving to the its final destination. So I hope this example would have cleared about the edge computing, how it is actually works. Now let's try to understand what are the typical differences between the edge computing and the cloud computing. Okay, so the first difference will be the programming part. So in programming, like how it is different in the cloud computing and the edge computing. So in cloud computing, because it is a kind of centralized application, because whatever is coming from different direction, that will come to one single centralized application. You have written different devices, whether it is the mobile device, web application, desktop application, whatever instructions they are giving, that are just landing to that centralized application which I have built, let's say on any of the cloud platforms. So that is the central application. And I would have used some sort of whatever kind of platform I have used, I would be using some specific set of language or instruction which that platform can understand, right? So that is one of the differences, right? You will be some language specific when you are working on a cloud computing related or a solution which is completely cloud agnostic. But in the edge computing, you are just completely independent of it, because let's say I have one device here, let's say all kind of mobile devices which are interacting on all kind of desktop application, all kind of web application. So I can even use different implementation for it, which can use different programming languages, let's say for the edge computing applications, or the kind of layer I have built which will work as a edge computation for the IoT devices, that can be in a different language, right? For the desktop, it can be in a different language. For the web application, it can be a different language. So that's the one difference between the cloud and edge computing. Next is the security. So edge computing actually needs a comprehensive security strategies. Why? Because we are adding something, again, extra layer which is just near to the data source, right? So there are very high chances, there will be very typical chances, you can say, of any kind of malicious activity which can happen, and the communication can be breaked, right? Your device which is actually sending some data or some instruction to the application, that can be breaked. So we need to while building these like edge computing related things, we need to take care of these things for sure. Like extra sophisticated security implementations will be needed, but this is not the case with the cloud. It needs less comprehensive protection plan, because most of the things will be taken care by the like actual cloud platform itself. On a very minimal level, those things will be secured, but we can put more extra security layers as well. And those security layers are very like even easy to implement as well. It's just like we need to finalize what are the best security aspects we want to cover. Let's the relevant organizations, right? The differences will be, so who should be actually bother about the edge computing, and who should be actually bothering about the cloud computing. So while I was describing about the edge computing, so I raised one point, the latency. So if you are an organization who really cares about the latency, best user experiences, right? Let's say you don't want to give any kind of lag to your users, right? Let's say they are using your services, and after 1-2 minutes they are getting some responses and everything, because they are they are located in a very far location, right? Which is let's say like 1,100 k's of miles away from the actual location where the actual computation or the data center is there, or any wherever I have hosted my application. Okay, so in that case, obviously you will be getting response after some seconds or minutes if this centralized application created on a particular cloud platform. But the edge computing is something which can definitely help that kind of organization to give to get the very minimum latency. Okay, and that is what, if you are someone who cares about the latency, then edge computing is best fit for you. If not, you can just survive with that kind of lag in the computation, then cloud computing is best for you. Next, the operations, the difference operation, like mostly on the system itself, like whatever computation will be happening. So there the pre-computation, I talked about the pre-computation part, right? The processing will be happening here, and then actual thing will be transferred to the main computing part where will be happening. But here since it's a centralized application in the cloud computing, so every computation will be happening here itself. No pre-computation, nothing will be happening on the data source side itself. So whenever I'm saying that edge computing, don't just consider everything I just need to put extra layer. Even the application could have been designed in such a way that pre-computation is actually happening in your device itself, let's say your laptop, or even let's say your a mobile device, because some minimalistic computing facilities need to be required, right? And that can be built in such a way that it is happening at your end. So this is the thing with the differences with the edge computing and the cloud computing. So first, programming, the security. Third is the organization, who should actually care about it. Fourth is the operation, like who will be doing the actual computation if we use the edge computing part and if we use the cloud computing part. All right, so now let's talk about the pros and cons of the cloud computing and the edge compute. So first, let's understand about the edge computing. So the advantages or the benefits, we can say, first, the low bandwidth, the latency, because the pre-computation will be happening on the data source and as well, or even the machine itself. And the next is the high security. And why high security? Because here computation or actual data which is needed for the computation, right? The pre-computation and anything that will be done here itself on your device itself or something like that, or even the edge. So your actual data won't be transferred to any of the cloud location or like any of the destination location. So here the chances of the data leaks or the data stealing is very less here. Third is the quick decision making. So here, since the pre-computation is happening here, and here communication time will be very less. So whatever decision we want to make, that can be quickly done. And the example I took, right, where I need to just raise the alarm or trigger any kind of alarm as soon as some motion is happening, right, in that secured building. And here the computation was actually happening on the data source and as well. I just quickly took that decision and just transferred the trigger or whatever call was that. So these three things, like the most important benefits or the advantages of the edge computing. Now let's look at the some disadvantages or risk with the edge computing as well. So the first is control and reliability. Here edge computing is something, as we said, will be something maintained on near to the data source or even in the device itself. So completely we cannot say it's a very reliable or control, like only one single effort or only one dedicated authority can look into it and take a control of it. No, because things are segregated. It's a decentralized mechanism in the edge computing. So human intervention will be needed and complete user attention will definitely needed if we are going ahead with the edge computing. And the second is the compatibility. Why compatibility? Because the concept of edge computing might not be fit for every use case, because sometimes what can happen, those kind of data sources might be generating very huge amount of data, right, which might not be handled with the edge computation what we are doing. So in that case it becomes really difficult, right, in order to find some compatible solution or compatible edge in order to cater that kind of architecture. So this is also one of the disadvantages of the edge computing. And now let's talk about the advantages of cloud computing. So first is the productivity anywhere. That means it's a complete centralized application for you. So wherever you are located, right, you don't need to bother about it, because sometimes let's say that edge somehow got failed, right? So there would be no way to interact with your server or somehow, right, to get the response or anything. But here it's a complete centralized. This is the only center you can get anything from here. If this is down, obviously they will take some downtime, and like after that you will start getting the responses, but there are no failure of chances from the source end itself, right? You are just making a call, you are getting the response, and that is something like you are sitting anywhere and like accessing the whole thing, because it is located at some center location. And second is the low cost, because here it will be a complete centralized application which will be completely hosted on a cloud platform. And nowadays cloud is something which you can get on demand and very cheap as well, right, in comparison with the on premises. But when we talked about the edge computing, so in edge computing you also need some capabilities to compute doing the main computation, but for the pre-computation or kind of decisions you want to take on in an earlier phase, right, or even the data source, and you need to add some extra capabilities which will increase your cost. But the advantage is something you are giving the better user experience or what your users are experiencing. So if user is getting a good experience, they can even pay you on top of it something. And that's how these kind of businesses are actually holding their backs in these kind of businesses, because they are giving the good experiences with the help of the latency. And third is very very powerful in terms of the data storage, because nowadays memory is something which you shouldn't bother about. If you are on a cloud, you shouldn't bother about it at all, that if I have increased 1 terabyte of the data, I cannot move further or anything, my application will crash, because massive amount of data you can nowadays store on the cloud. So that's why it is very very powerful in comparison with the edge computing, because that was one of the drawback. Those devices or those edges might not be able to handle that massive amount of data. Now let's talk about the risks with the cloud computing. So first is the data related, data information related risk, because everything will be sent to the cloud platform and there might be possibilities of data leakage and data stealing. So that is one of the potential risks with the cloud computing. And next risk, basically the longer outage time. So even if you are very very well aware with the tech industry, so there were multiple instances when the whole when the complete data centers or even some the routers or potential single point of failures completely down, and that impacted so many businesses, because nowadays very very large enterprises are using these kind of cloud providers like the AWS, Azure, GCP for their solutions. If anything breaks out on their end, obviously it will take time for them to restore or to just fix it, and that's how this longer outage time might lead you towards the money losses as well, because if your business is critical, you so those were some advantages, disadvantages between the edge computing and cloud computing. So the future is definitely really bright in the edge computing section as well, as soon as we are like getting more fascinated about the streaming application like Netflix, Amazon, Hotstar, and they are like doing their own stuff as well to make their application more reliable, right? And trying to give really really great user experience, because we are someone who loves our time, right? We cannot probably wait for anything which is actually something, let's say, exciting. So I would definitely wouldn't want to wait for 2-3 minutes for that to happen. I would definitely expect a response in a just fraction of seconds. So that's how latency is something which can lead some company in a great opportunities of businesses. And that's how even the companies are also taking this edge computing is a very very serious concept in their solutions and in their products and architectures. That's why the future is the really really amazing in the edge computing. So that's what I had for you guys in this video. I hope you would have liked this information about the edge computing and the cloud computing. So start exploring it, very very unique concept and very very trending. And let me know your thoughts in the comment section as well, if you have explored anything related to edge computing and cloud computing. And please feel free to put your suggestions in the form of query. We will answer those things. And yes, like this video in big numbers so that it can reach to maximum number of people. And I will see you guys in the next video with another amazing concept.